All right, this is section 5.1, part 4. All right, and then last but not least, we're just going to talk real quick about the 3 different types of probability that you went over in your interactive assignment. All right, so we have 3 types of probability, and I want to talk about those really quick. Our empirical probability, or what I sometimes think of as experimental probability. I don't always use that term, but I think it's very helpful to think of it that way, because this is when we don't have some of the situations like we have with our classical or theoretical, which I'll touch on next. But hopefully you've already watched the videos in the interactive assignment, and so you know what these 3 are. So our empirical probability takes our probability of some event, and we're just going to have to figure out, the number of times, something, I'm just going to say E, occurs. Oops. And we're going to divide by the total number of what we'll call trials. Because whenever we're doing this, whether we're rolling dice or I love the pass the pigs example. We're rolling those pig-shaped dice. I have that game. It's great. So we're rolling those dice. We're rolling those pigs. We're flipping a coin. We're trying to figure out about a thumbtack. Drop that thumbtack multiple times and see, is that empirical? Or is that more likely to land on with the point sticking straight up, or is it more likely to land with that tip down? And so we have to experiment with those things, and we just have to see what happens. And that law of large numbers, that's where it comes in. So law of large numbers is exactly what empirical probability is based off of. The more trials that we have, the closer we're going to get to the true probability. With our classical probability, which I tried to type this in the notes, but I will a lot of times end up calling this theoretical probability. And just because that's the way I learned it, I didn't learn it with the term classical. I'll try to use classical just to be consistent. But in this case, try to remember that theoretical and classical mean the same thing. But with our classical probability or our theoretical probability, we have to have equally likely outcomes. So that means that each time we do something, we're going to need to see that it has an equal number of possible outcomes. Now, this doesn't necessarily mean that, how do I put this? So this could be that the probability of certain things are not necessarily the exact same. For example, I've got a little deck of cards, and it's a made-up deck of cards. But let me bring that up so we can look at it. Okay, so here's my deck of cards. I usually say that this is an exploding snap deck, or cards from an exploding snap deck. That is a Harry Potter reference. If you don't like Harry Potter, it doesn't really matter. I just made these up anyway. But there are stars, hearts, lightning bolts. There's a smiley face. There are gray cards, black cards, and white cards. Now, if I look at the probability of getting a star, the probability of getting a heart, probability of getting a lightning, and the probability of getting a smiley, well, let's see. Probability of getting a star would be 5 out of 12. Probability of getting a heart would be 3 out of 12. Probability of getting a lightning would be 3 out of 12. And the probability of getting a smiley would be 1 out of 12. Well, let's look at our rules of probability. Of course, everything is between 0 and 1. When I add these up, 5 plus 3 is 8. 8 plus 3 is 11. 11 plus 1 is 12. 12 over 12 is 1. So both my rules of probability work. I do have all my probabilities. These are not equally likely. 5 out of 12 is not the same as 3 out of 12. Now, heart and lightning are. But then 1 out of 12, that one's not equal either. So when we say for theoretical probability that we have to have equally likely outcomes, what it means is that for each and every one of these cards that I have, now, star, heart, lightning, and smiley, I can get the theoretical probabilities because the cards are equally likely. If I were to shuffle those cards up and draw 1, I have a 1 out of 12 chance of getting every single one of those cards. Now we're going to continue into section 5.2 where we talk about or. And what happens when I say what's the probability of me getting a star, what I'm technically saying is that I could get this card or this card or this card or this card or this card. And if you've already moved on to section 5.2 interactive assignment, you know what that means. I will talk about it more when we get to the section 5.2 videos. But that's what, when we're talking about equally likely outcomes, we mean each individual possible outcome. So I have all these different cards. Each card is a possible outcome. Then I can come up with my theoretical probabilities. And then last but not least is our subjective probabilities. And this one's kind of the hardest one to really define because it's almost like the definition is that it can't be done either of the other two ways. So we either can't run an experiment or run a bunch of trials and figure out what it should be, or the outcomes are not equally likely. And so if you think about like weather, well, it could rain, it could be sunny, it could be cloudy, we could have a tornado, we could have a snowstorm, we could have hail, but that doesn't mean that there's, I don't even know how many things I listed. If I end up finding 10 different weather things that could happen in East Tennessee, it doesn't mean each one of them is a 1 out of 10 chance of happening every day, right? If I tried to tell you there's a 10% chance of snow today, you all would laugh at me because it's the middle of June and we had 97-degree weather this past weekend. So obviously we're not going to get snow. But we also can't go back and say, okay, well, let's look at the past 100 years. And I'm going to look at the weather on June 8th for the past 100 years. And I'm going to say that there's, for those 100 years, and I'm making this up, although I could look it up. In Knoxville, it rained 38 times in the past 100 years on June 8th. So there's a 38% chance of rain. That would be trying to use empirical probability. We can't do that either. That's just not possible. That's not how weather works. Especially in East Tennessee. But that's not how things work. So subjective probability, we're not going to be able to use one of the other two methods. So that's weather. Same thing with sports. And the easiest one to think about is the Super Bowl. So there's been 54, I think that's what we just had. So 54 Super Bowls that we've had. And I believe the Steelers have won like 6 times. Let's see here. Yes, that's right. They've not won since 2009. And so I would not be able to say empirically that the probability of the Steelers winning Super Bowl LV, so that'd be 55, is 6 out of 54. Because they've won 6 times out of the 54 times that it's been played. That would be empirical. And that doesn't work. So just as a, before we even get any further, just go ahead and know that's not going to work. Similarly, I can't say that the Steelers winning Super Bowl. Oh, should be a P there. There we go. 55 would be 1 out of 32. There are 32 NFL teams. The Steelers are one of those teams, and so by classical probability, they would have a 1 in 32 chance of winning. Well, I think we're all aware that NFL teams are not equally likely to win the Super Bowl. So that's out. And so instead, we have to use subjective probability. And people do this. Some people just make stuff up. Some people do, and I guess a more educated guess by trying to use strength of schedule and how they played last season, how they played, as you move on and get closer to the Super Bowl, how well have they done against the teams that they've played. They even have these computer programs that kind of just calculate all of this probability over and over and over again. But eventually, somewhere in there, to create the formulas, to create the weights for what these different things are worth, somebody had to make a judgment call. And I actually have a friend who I taught with when I was teaching at Carson Newman, who does the Massey ratings. And his name is Kenneth Massey. And he's come up with this formula, and he's been on, his formula has especially, but he's even been on and to explain like why his picks are, and it's for college football, I think, more than NFL. But somewhere in there, he had to make a decision. Mostly it's computer-generated picks, but he had to weight the things, and he had to put some judgment calls in there somewhere. So I looked it up, and according to, I don't know, the Sportsbook Wire, .usatoday.com, random article that literally just came up, one of the first things I got for when I Googled it, says that the team, the Steelers, has a, let's see here, so probability, actually, I'm just going to copy and paste that because that's getting tiring to write. So it says that the Steelers has a 0.0526 chance of winning the Super Bowl in 2021. So that would be Super Bowl 55. And of course, this is without anything. We don't know anything yet about they haven't started the season. That won't happen until after summer, of course. And but they've already got that probability up. So that is using subjective probability. And that's the only way we can come up with a probability for that type of situation.